Let's talk about software quality. Quality was defined as conformance with a detailed product specification. The underlying assumption was that products could be completely specified and procedures could be established that could check if a manufactured product complied with the specification. But of course, products will never exactly meet a specification, so some tolerance was allowed. If the product was almost right, it was classed as acceptable. Software quality, however, is not directly comparable with the quality in manufacturing. It may be impossible to come to an objective conclusion about whether or not a software system meets its specification. This is for the following few reasons. It is difficult to write complete and unambiguous software specifications. Software developers and customers may interpret the requirements in different ways, and it may be impossible to reach agreement on whether or not software conforms to its specification. Second, specifications usually integrate requirements from several classes of stakeholders. These requirements are inevitably a compromise between all stakeholder requirements and may not include the requirements of all stakeholder groups. The excluded stakeholders may therefore perceive the system as a poor quality system, even though the system implements the agreed upon requirements. Thirdly, it is impossible to measure certain quality characteristics, for example, maintainability. So you cannot measure these characteristics directly and they cannot be specified in an unambiguous way. Because of these problems, the assessment of software quality is subjective, where the quality management team has to use their judgment to decide if an acceptable level of quality has been achieved. The quality management team has to consider whether or not the software is fit for its intended use. This involves answering a few questions about the system's characteristics. A few questions have been listed here on the slide. Have programming and documentation standards been followed in the development process? Has the software been tested properly? Is the software sufficiently dependable to be put in use? Is the performance of the software acceptable for normal usage? Is the software usable? Is the software well structured and understandable? There is a general assumption in software quality management that the system will be tested against its requirements. The judgment on whether or not it delivers the required functionality should be based on the results of these tests. Therefore, the QA team should review the tests that have been developed and examine the test records to check that testing has been properly carried out. In some organizations, the quality management team is responsible for software testing, but sometimes there is a separate testing team set up and made responsible for this. Therefore, software quality is not just about whether the software functionality has been correctly implemented, but also depends on non software or non functional system attributes. There are about 15 important software quality attributes as shown on the slide. These attributes relate to software dependability, usability, efficiency, and maintainability. It is definitely not possible for any system to be optimized for all of these attributes. For example, in improving robustness may lead to loss of performance. The quality plan, therefore, should define the most important quality attributes for the software that is being developed. An assumption that underlies software quality management is that the quality of software is directly related to the quality of the software development process. This again comes from the manufacturing systems, where product quality was related to the production process. A manufacturing process involves configuring, setting up, and operating the machines involved in the process. Once the machines are operating correctly, quality naturally follows. You measure the quality of the product and change the process or tweak the process until you achieve the quality level that you desire. The picture on the slide illustrates a process based approach for achieving product quality in a manufacturing firm. You define a process initially, use this process to build the product, develop the product, improve the process continuously, assess the quality of the product. If the quality is okay, make this process as the standard process. If not, improve the process and develop the product using the improved process. There is a clear link between the process and product quality in manufacturing because the process is relatively easy to standardize and monitor. Once manufacturing systems are calibrated, they can be run again and again to output high quality products. However, software is not manufactured, it is designed. In software development, therefore, the relationship between the software process quality and the product quality is more complex. Software development is a creative activity rather than a mechanical process, as in case of the manufacturing industry. So, the influence of individual skills and experience in software development is predominantly significant. External factors such as novelty of the application, commercial pressure for an early product release will also affect the software quality irrespective of the process that has been used. There is absolutely no doubt that the development process used has a significant influence on the quality of the software, and that good processes are more likely to lead to good quality software. Process quality management and improvement can lead to fewer defects or bugs in the software being developed. However, it is difficult to assess software quality attributes such as maintainability without using the software for a very long time. Consequently, it will be hard to tell how process characteristics influence these attributes. Furthermore, because of the role of design and creativity in software process standardization becomes a stifle creativity, which leads to poorer than better quality software.